Alrighty, geometry friends, here we go. The last lesson from chapter 3, continuing with graphing lines in the coordinate plane. And this is going to be actually graphing the lines. Last chapter lesson was on slope. And so we have two key forms to define here as a part of our definitions. The first is slope-intercept form, and the second is point-slope form. And while, again, at just first mush of the brain, those sound very similar, you're going to want to note the difference because knowing the difference will make your life in geometry much, much better. Maybe even your personal life, but definitely your life in geometry. And paying attention to detail will make your general life much better. All righty, there you go. Sermon for the day. Slope-intercept form is y equals mx plus b. And it's called slope-intercept form because it has two key points. Trust me, the name in this case, sometimes names in math don't seem too meaningful, but this does. It's because it has the slope and it has the intercept. Okay, so from this form, when you look at it, you should know the slope of a line and the intercept of a line. And so the intercept, that's the b right here. This b specifically tells you the y-intercept. The y-intercept is where this line crosses the y-axis, and we'll do an example in just a minute. And so just from looking at slope-intercept form, you can say, oh, that line crosses at b, or whatever number actually is in the formula. The slope we talked about last lesson, that tells you the steepness of the line, whether it's positive or negative, flat or undefined. And that, of course, is the m right here. So this is your same letter we used last lesson. That is your slope. So by looking at this form, I can look at a line and go, okay, I know where it crosses the y-axis, and I know how much it tilts. And so basically, this is perfect for graphing lines. Okay, we're going to talk about this in a moment, but the whole point of this is that you can use slope-intercept form to graph your lines very, very easy. If you hate graphing lines, it's just you haven't quite got how simple it is, and I hope to help you with that. So for example, if I change this and I say, here's an example, we have y equals 3 over 2x minus 1. Okay, so what that tells me immediately is that this line crosses the y-intercept at -1 and that it has a slope of positive 3 over 2. And so I can take that, and without plugging in a single point, I can graph it. Let's see, hopefully my graph's big enough, but let's try it. So I can see here's my y and my x-axis. So first of all, make sure you know which axis is which. Y-intercept is where it crosses the vertical line. So that means it crosses this axis right there. I know that that point is on the line, is on this line. And so that's always my starting point. So you always start with your y-intercept. And then from there, you just count out your run, whatever your rise and your run is. So this is 3 over 2. So then I can say, well, the next point must be up 3, 1, 2, 3, and over 2. That would put it right there. And then I could repeat it one more time just to make sure I get a nice straight line. And from that point, I can go up 3, rise 1, 2, 3, run 1, 2. And so there's my line. And if I connect it, I now have a graph of that line, y equals 3 over 2x minus 1. And any point that I plugged in for x, I would get a y out that falls upon this line. For graphing, it's very, very easy if you know what the letters mean. Slope-intercept form is super valuable and super common, and you want to use it all the time because, again, it makes graphing very quick and easy. So the second form is point slope form. And again, this one's a little messier, oftentimes in the eyes of students, but just as practical in that it has two key elements. It has a point and it has a slope. Okay, and so this, when we write it out, it means that we have a point from the line and we have the slope of the line. Well, here's our slope again. It's always m, so that's nice to be consistent. Where's the point? The point is these noted x and y coordinates. So in other words, that when they give you a point, like so, if they give you a line and they say, oh, the line has a slope of 3 and it goes to the point 1, -5. Well, that's where those second x, that's that y1 and that x1 are where those coordinates would go. And so this is the format that of when finding the equation of a line. So if they don't want you to graph it yet, but they're just asking, well, even what's the equation of a line? You can find it by finding, first of all, a point from the line and then the slope of the line. If you find those two things, you plug them into this bad boy and you're rocking and rolling. Okay, let's just go ahead and do an example. I'll do this one in green to make it stand out. So say they tell me that I have a slope, we'll go with something easy, a slope of 2. And it's a line that goes through the point -2, 1. Keep the numbers small so our graph fits. Okay? And then they're going to say find the equation. They might say graph it, but no, they're going to say find the equation. So how am I going to find that equation? Well, I plug them into point slope form. And you got to have to memorize it. Y minus y1 equals m times the quantity x minus x1. Okay? And so we can plug these things in. We have get the right color here, y minus, okay, and then what's my y coordinate? My y coordinate is 1. Make sure you know your x and your y, okay, equals, what's my slope? My slope is 2, okay, times the quantity, and then x minus my x coordinate, which is -2. So there you can see, and maybe I should have, written this in red just to kind of emphasize it or keep it consistent. So this form is where you plug in your slope for m, and then you plug in your coordinate, your y on the left and your x over there. And now this is the equation. Y minus 1 equals 2 times the quantity x minus -2. And now if I just solve this, I'm going to get an equation that will allow me to graph. Watch. So y minus 1 equals, and first I'm going to simplify this, 2 times x, and x minus -2 just simplifies to x plus 2. Okay, I'm going to distribute, so y minus 1 equals 2x plus 4. And then I'm going to add 1 to both sides, so then I get y equals 2x plus 5. Now, why is that such a valuable simplification process? Well, it's valuable because now this is my mx plus b. I have my m right here. There's my slope. And I know where it crosses the y-intercept right here. And so that is my y-intercept. Alrighty? And so the whole point of point slope form is to be able to take a point and a slope and write it as an mx plus b equation. Let me put this up so you can see it better. So that then I can go and graph it like we did with this first one. So slope-intercept form, and that's actually just our first question. First question is, when do you use slope-intercept? When do you use point slope? Well, let me just reiterate it. Slope-intercept is for graphing. Okay, it allows you to graph the thing very easily using the two key elements, the slope and the y-intercept. Okay, pretty simple. Whereas the point slope form is for finding the equation. Okay, using the slope and a point. And as I'll demonstrate in one of the castings, not only using a point and a slope, but I'll also say using, I'm going to amend this, using just 2 points. Because you can actually just use 2 points to find your slope. And so that's what we're going to do here for number 2, is from just 2 points, I should be able to find the slope and then be able to use point slope form to find the equation of my line. And then once I have the equation of my line, I can graph it. So let's look at number 2. Number 2 is just a practice. So I've been given 2 points, and your first goal, and this is just your bread and butter graphing and algebra. So I can't emphasize how important this lesson is, that you want to be good and confident in it. So keep practicing and asking questions till you've got it. But let's start. I have 2 points. I need to find an equation, so that means I'm going to use point-slope form. Point-slope form, let's review, would be y minus y1 equals m times x minus x1. Okay? I definitely have a point, but I don't have a slope. So my first goal is I've got to find my slope. Now, if you remember from last lesson, we know how to do that. We just need to subtract our y's, 5 minus -4, over our x's, our runs, our rise over our run. So 1 minus -2. All right, notice I started with the 5, I went to the 4, so I want to start with the 1 and subtract the 2. If you reverse the order in between, that will mess you up. So let's see, 5 minus -4 is positive 9, over 1 minus -2 is positive 3. And now I can simplify that like a fraction. 9 over 3 simply reduces to 3. So my slope, I just found it. My slope is 3. So now I have a point and a slope, and I can plug it into my point slope form on the left, and we can find the equation of the line. Let's do it. How fun. Okay, so notice we actually have 2 points. We have 1, 5 and -2, -4. You may use either one. It's up to you. It doesn't really matter. Just stick with the same one. I'm going to stick with the one without negatives because sometimes negatives complicate my life. So let's plug it in. So I'm going to go y minus my 5, because that's my y value, equals m, which is 3, times x minus my x that goes with my 5, which is 1. So there we go. We've plugged in our point and we've plugged in our slope. We had to find the slope ourselves. Okay, now I'm going to distribute. Same process we did a minute ago. Y minus 5 equals 3x minus 3. Now I'm going to add 5 to both sides so that y will be alone. And so I'm going to get y equals 3x and -3 plus 5. I should be a good algebra student and write this in. Plus 5 plus 5. That cancels out. And so now I get 3x plus 2. Okay? And now I have my my slope intercept form. I could graph this. I didn't ask you to graph it, so I'm not going to. Oh, actually, maybe I will. Just to demonstrate it. Show you how easy it is. So we can graph this by, first of all, the 2 is the b. That's my y-intercept. So that means this thing crosses the y-axis right there at 2. And then it has a slope of 3. Notice 3 is not a fraction, but if it's a whole number, it just means the denominator is 1. So this is the same as 3 over 1. So from my y-intercept, I just need to rise 3, 1, 2, 3, and run 1. And then rise 3, 1, 2, 3, and run 1. And so there is the graph of the line that goes with this equation of the line that came from those 2 points, over 1 up 5 and back 2 down 4. And notice both of those points are on this line. Over 1, 1, 2, 3, 4, 5. There's my point. And also back 2, 1, 2, 3, 4. My lines are a little crooked, but the point is actually right there. Okay? So I even know my answer's right. I can be confident. Okay, so that's the first part. The second part is find a line that is parallel to this line that passes through the point. Let me reference my screen real quick. What's the point? Passes through 3, 3. Okay, so now we need to do the same thing, but we need a line that's parallel to this that goes through the point. Let me write this one down. And it has to go through the point 3, 3. Well, the key here is how do the slopes of parallel lines compare? I know the slope of this line is 3, so what's the slope of a parallel line? That's right, they're congruent. So I know my new slope is also 3. So in other words, this is just going to now be a repeat of what I just did, but I'm going to do it again with a new point, 3, 3, and the same slope, 3. So let's just practice it one more time. till we get good at it. So what's my point slope form? Because notice, look, I have a point and I have a slope. So we just do y minus 3 equals, wow, there's a lot of 3's in this problem, equals my slope 3 times x minus 3. Wow, should have thought that through as an example, but it makes it easy. We know we've plugged everything in correctly. Alrighty, so now let's work this out. Let's distribute. Y minus 3 equals 3x minus 9. I'm going to add 3 to both sides. And so we get y equals 3x minus 6. Okay, so we got minus 6, negative 9 plus 3. So now let's go ahead and graph this and see if it is in fact parallel. Here's my y-intercept. Here's my slope. Let's try it, and then we'll be all done. So my y-intercept is at negative 6. 1, 2, 3, 4, 5. That would be way, oops, right down here. So this one crosses the y-intercept much lower. And then it rises 3, 1, 2, 3, 1, 1, 2, 3, 1. And so here is the line roughly drawn. But you can see, oh, very nice. They are, in fact, again, not perfect, but they're parallel. Also, does it go through my key point, 3, 3? Let's see. 1, 2, 3, 1, 2. Yes, it does. There's my key point, 3, 3. So I did exactly what it asked. And again, how did I do that? Let's quickly review. To do the second line, I had to know that the slopes of parallel lines are the same. So once I knew the slope of my first line was 3, I knew the slope of my second line would be 3, and I just repeated the point slope process. At the beginning, I had to get started. I needed a point and a slope, and I knew I had to remember that from 2 points, I can find the slope by subtracting the y's over subtracting the x's. And that's how I found the first slope, plugged it in, and found my equation. Okay, I'll leave it at there. Ask questions tomorrow, and we'll get good at graphing lines using slope-intercept form and good at finding the equation of lines using point-slope form. All right, talk to you soon.